Hey there, fellow curious minds. Have you ever looked up at the night sky and wondered about the incredible universe we live in? It's mind-blowing, right? But wait, there's a puzzling question that has baffled thinkers for ages. If the universe came from nothing, who created the nothing? Well, hold on tight as we embark on a fascinating journey to explore this mind-boggling mystery. We've gathered some of the brightest minds, from scientists to philosophers and even theologians, to help us understand this mind-bending concept. Imagine a time when there was nothing. No stars, no planets, nothing at all. How can something as vast and incredible as the universe emerge from absolute nothingness? It's like trying to solve the ultimate cosmic puzzle. But don't worry, we won't leave you in the dark. We'll guide you through the wonders of existence, dive into the strange world of nothingness, and explore the ancient question: how can something come from nothing? Are you ready to stretch your imagination to its limits? Because this journey will challenge everything you know and take you on an adventure of a lifetime. Don't forget to hit that subscribe button and turn on the notification bell so you won't miss a single moment of this mind-expanding cosmic quest. Get ready to uncover the secrets of the universe and explore the incredible paradox of nothingness, all in easy, engaging language that'll leave you saying, "Wow, I never thought about that." The end as the beginning. The end and the beginning are intertwined, regardless of whether we talk about the Big Rip, the Big Crunch, or the Big Freeze. These theories may differ, but they all point to the same outcome: the eventual end of the universe. According to these ideas, at some point in the distant future, the last star in the cosmos will burn out, leading the universe into a dark and empty state. During this dark phase, gigantic black holes will consume any remaining matter before eventually evaporating themselves, resulting in a final act of destruction. As space expands, even the faint light emitted by evaporating black holes will disperse, and the cosmic activity will come to a complete standstill. This is a widely held view among scientists, and many researchers see this as the ultimate end of our galactic home. However, some experts propose a different perspective, suggesting that this end could be the beginning of a new universe. They believe that the dark, cold, and empty universe that follows the destruction might be the foundation for the next Big Bang, giving rise to a new cosmic cycle. Now, let's ponder another intriguing question. How did the first physical matter come into existence? To explain the emergence of stable matter from atoms or molecules, we must consider that such matter did not exist during the Big Bang or the subsequent millennia. However, we do know that the first atoms formed from simpler particles when external conditions cooled enough to allow for the formation of complex, stable matter. These atoms eventually fused in stars to create heavy elements. Although our current understanding does not explain how something can be born from nothing, it is fascinating to trace the timeline back even further. Protons and neutrons, which make up the nucleus of atoms, are believed to be the earliest long-lived matter particles in galactic history. They are thought to have been created immediately after the Big Bang, even before what we recognize as matter existed in the classical sense. Fortunately, through physics, we can explore the processes that occurred before the birth of stable matter, delving deeper into the mysteries of our universe's origins. The Planck era. In the early moments of the universe, there was a period known as the Grand Unified Theory era. During this time, three of the four fundamental forces of physics, the strong force, the weak force, and the electromagnetic force, existed as a single unified force. The physical world was filled with short-lived elementary particles, including quarks, which make up protons and neutrons. In this era, there was a balance between matter and antimatter, with each type of matter having an almost identical but opposite antimatter counterpart. When matter and antimatter particles met, they annihilated each other. These particles seemed to appear and disappear in what we call the vacuum, a seemingly empty space that is actually filled with energy fluctuations. But how did space and time come into existence? During the Planck era, which followed the Big Bang, even space and time were subject to quantum fluctuations. To understand this period, we need a complete theory that unifies quantum physics with relativity, and theories like M-theory and loop quantum gravity are promising candidates. In the Planck era, our usual understanding of space, time, and cause and effect breaks down, and they are considered emergent from quantum processes at a microscopic level that we currently can't fully comprehend. While our current theories are not yet able to explain all the processes of this era, physicists are actively working on developing better theories. In summary, the grand unified theory era was a time when fundamental forces were united, and the early universe was filled with fleeting particles. The Planck era followed, where even space and time were influenced by quantum fluctuations. While we are still exploring these fascinating times, we have not yet found any confirmed cases of something forming from absolute nothing, creator, multiverse, or cycles. The universe's state at the beginning of the Planck era, which is the very early stage of the universe, is currently impossible for us to decipher. Therefore, all theories related to this period are highly speculative. Some theories try to explain this mystery by proposing the influence of a divine creator, while other less religious explanations consider the existence of a multiverse as a promising idea. According to the multiverse concept, our cosmos is just one of many universes in an infinite chain of other universes. On the other hand, there are cyclic models that suggest the universe undergoes a constant cycle of destruction and rebirth. One prominent supporter of this idea is Roger Penrose, a Nobel Prize-winning British physicist, who introduced the theory of conformal cyclic cosmology. According to this theory, there are intriguing mathematical similarities between the Big Bang and the distant end of the universe. In fact, these two states are even identical when taken to their limits. This led Penrose to a paradoxical hypothesis. The complete absence of matter gave rise to all matter in the cosmos. In other words, the Big Bang originated from something that resembles nothing, which occurs when the matter of a universe is annihilated by black holes that subsequently decayed into photons. The question then arises, how can a cold, empty universe transform into a hot, dense universe? The answer lies in a mathematical process called conformal scaling. It's a geometric transformation that changes the size of an object while preserving its shape. Through conformal scaling, it's possible to show that the shapes of the spacetimes of the cold, empty state and the hot, dense state coincide. In simple terms, the hot, dense state exists because of the cold, empty state. As a result, the end of an expanding cosmos is followed by a new Big Bang, the search for the nothing. Let's imagine that a controversial theory proposed by Penrose is proven true one day. Even then, we would still not have a clear answer to some deep questions about the origins of the universe. These questions include how something can emerge from nothing, where physical reality comes from, why the universe follows a cyclical system, and why anything exists at all instead of nothing. These philosophical questions naturally arise when discussing such fascinating topics. However, for this video, we'll focus on the physics aspect. Science offers different approaches to understand the possible background of cyclic universes. One idea suggests there might be no physical explanation at all, while another suggests an endless cycle of repeating universes, with each new universe influenced by the quantum state of the previous one. Another perspective proposes a single cycle of the universe, where the beginning is defined by a property of its end. These fundamental questions may remain uncertain, but this very uncertainty is what makes the topic so intriguing. Researchers continuously study distant areas of space to gain insights into our galactic environment. However, sometimes valuable information comes to us when smaller galactic objects enter Earth's atmosphere, providing important clues about their origins. One such event, which happened in Papua New Guinea a few years ago, was surrounded by mystery as it was hidden from the global public: the secret meteor. In 2014, something extraordinary happened over Papua New Guinea. On January 8th, a fast-moving object entered the Earth's atmosphere and burned up. This cosmic projectile was traveling at a mind-boggling speed of over 120,000 miles per hour, much faster than typical meteorites in our solar system. In 2019, experts conducted a study on the remains of the meteorite and made an astonishing discovery. They found that this small meteor, about 2 feet in diameter, was almost certainly from outside our solar system, likely coming from a distant alien planetary system within the Milky Way. However, the findings were kept secret for a long time because some of the data required to verify the calculations were classified as top secret by the US government. Now that the interstellar origin of the object has been confirmed, it becomes the first ever detected interstellar structure in our solar system, surpassing the previous record holder, Oumuamua, discovered in 2017. Amu Shuraj, a theoretical astrophysicist from Harvard University, led the study and plans to publish the results for the international scientific community to analyze further. The meteor burned up over the South Pacific, and there is a possibility that some fragments may have fallen into the sea. Shuraj is discussing with other experts the idea of an expedition to search for these interstellar fragments lying at the bottom of the ocean. In simpler terms, a superfast object from outside our solar system burned up over Papua New Guinea in 2014. Scientists now believe it came from a distant alien system, and its discovery was kept secret until recently. A Harvard astrophysicist plans to share the findings so that researchers can explore the topic further. There's a chance that some of the object's fragments may still be hidden in the ocean, waiting to be found and studied. Flying mystery. Before the true background on the origin of the 2014 meteor was revealed, a fascinating discovery was made with the help of the Pan-STARRS telescope in Hawaii. An object named Oumuamua was added to the star charts on October 19, 2017. It was considered the first object observed within the solar system to be classified as interstellar. Interstellar objects are those bodies that are not bound to a specific star and move through interstellar space. Oumuamua was on its way back to interstellar space when astronomers became aware of its existence. However, it had passed near our Sun and Earth, raising questions about its nature. Initially, experts thought Oumuamua might be a comet, but its lack of a characteristic tail challenged this hypothesis. It reached the apex of its orbit on September 9, 2017, moving at an incredibly fast speed of over 50 miles per second. It came close to our Sun, about 20 million miles away, and later passed Earth at a distance of approximately 15 million miles before heading towards the constellation Pegasus. Some observations about Oumuamua were unexpected and still not fully understood. It appeared to slow down less after its solar passage than predicted, which couldn't be entirely explained by gravity. Additionally, the object showed dramatic fluctuations in brightness, suggesting it had a cigar-like shape and tumbled through space rather than rotating around a fixed axis. These intriguing characteristics led to speculation about the possibility that Oumuamua was not of natural origin, but potentially artificially created. Scientists are still studying and analyzing this mysterious interstellar visitor to gain further insight into its true nature. An alien spacecraft. Controversial speculation about the object known as Oumuamua was fueled by the absence of dust particles nearby and the assumption that it might not contain water, but be made entirely of metal. Experts suggested that its billion-year journey in space might have caused low reflectivity, assuming an albedo of 0.04, with an estimated mean diameter of about 700 feet. In November 2018, astrophysicists Avi Loeb and Shmuel Bailey made headlines by proposing an unconventional hypothesis to explain the absence of dust and orbital deviation. They suggested that Oumuamua could be an extraterrestrial solar sail sent by an intelligent civilization to explore our solar system. Other researchers did not categorically reject this idea. In December 2017, as part of the Breakthrough Listen research project, some researchers closely examined Oumuamua using the radio telescope at the Green Bank Observatory in West Virginia. The goal was to detect possible signals of artificial origin, although the chances were considered extremely unlikely. After 14 days of analysis in different frequency ranges, no evidence of an artificial background was found. Future investigations. To uncover the true background of our mysterious visitor, a direct investigation seems promising. However, intercepting a craft traveling away from us at over 15 miles per second would be virtually impossible using conventional space probes. New approaches are needed to solve this exciting mystery. One concept involves launching an unmanned spacecraft from our solar system using an explosive solid fuel engine. With fully developed technology, reaching the visitor, Oumuamua, could take 16 years from the launch of the spacecraft. Patience is necessary as we wait for this to happen. Some who doubt an artificial origin for Oumuamua speculate that it could be a fragment of a Pluto-like exoplanet, primarily composed of frozen nitrogen. During its interstellar journey, much of the nitrogen ice may have melted, reducing its original mass and giving it a flat form. Black holes are fascinating and mysterious entities in the cosmos. While many fundamental characteristics of these gravity monsters have been deciphered, one question remains unanswered. How are supermassive black holes formed? Although large representatives of these objects are found in the centers of almost all galaxies, their creation remains a galactic mystery. A recent discovery of the precursor of a supermassive black hole could bring some light into the cosmic darkness, but there are still puzzles to solve in the future. Mysterious omnivores. Whether it's matter, radiation, or any other form of information, anything that falls into a black hole cannot escape. This happens because of the incredibly strong gravitational force of black holes, which is a result of their extreme compactness. If a black hole had the same mass as our Earth, it would be no larger than a speck of dust. However, in reality, black holes in the cosmos are much more massive, exceeding the mass of our Sun by millions or even billions of times. There are different types of black holes, and one of the easiest to understand is the stellar black hole. These black holes are formed when a star of a certain size reaches the final stage of its existence and undergoes a supernova, shedding its outer layers. The remaining stellar core collapses under its own gravitational pressure, becoming an incredibly compact structure, a stellar black hole. Contrary to what one might think, black holes don't destroy everything that comes near them. Supermassive black holes, in particular, have important roles in the development of galaxies. Outside their event horizons, these massive black holes behave like conventional mass bodies. Other celestial bodies can even orbit around them in stable orbits, just like they would around any other object. A groundbreaking discovery. Stellar black holes and their supermassive counterparts behave differently. While we understand the formation of stellar black holes well, the birth of supermassive ones remains a significant mystery. Recently, astronomers made an exciting discovery with the object called Galaxies 7, which could be the precursor of a supermassive black hole from the early universe. Unlike previous distant objects that were either starburst galaxies with high star formation rates or quasars with active supermassive black holes, Galaxies 7 appears like a starburst galaxy at first glance. However, detailed observations in ultraviolet and infrared spectra reveal that a black hole is growing within it, possibly transforming into a quasar. The data collected aligns with theoretical simulations, and it's believed that the future supermassive black hole is still surrounded by gas and dust, which has not been directly observed before. Galaxies 7 is an essential candidate in understanding the link between starburst galaxies and quasars. Astronomers plan to use the James Webb Space Telescope in the future to study Galaxies 7 further, hoping to gain new insights into the mysteries of the cosmos. The telescope is set to begin its scientific service in a few months. Sagittarius A star. In the universe, Galaxies like our Milky Way are believed to have formed with the help of central black holes. However, the exact relationship between the formation of these black holes, stars, and planets remains unknown. Our Milky Way also has a central black hole called Sagittarius A star, which is about 4.3 million times more massive than our Sun and located about 26,670 light-years away in the Sagittarius constellation. Sagittarius A star was first observed as a strong radio wave source in the 1930s. In 1974, researchers identified it as a probable supermassive black hole using the National Radio Astronomy Observatory's interferometer. It was later confirmed through observations in the 1990s, and the discovery earned Reinhard Genzel and André Ghez the Nobel Prize in Physics. Near Sagittarius A star, various interesting events were observed, including stars and gas clouds orbiting the black hole closely. Some stars even belong to the Squishar class, a theoretical type of star intensely squeezed by enormous tidal forces. Additionally, 6 gas clouds known as objects have been detected moving in orbit around the black hole. Besides Sagittarius A star, there may be thousands of other black holes in the vicinity, and they might play a role in supplying material to the supermassive black hole through a process called galactic feeding. This theory suggests that smaller black holes capture stars in the outer regions of the galaxy and bring them closer to Sagittarius A star, where some stars eventually get consumed. The universe is known for its vast diversity and powerful forces, including supernovae, which occur when massive stars end their lives explosively. Recently, researchers identified a new record holder for a nova, a stellar explosion, with incredible emissions during the process. Please note that scientific discoveries and knowledge are continually evolving, and the understanding of these topics might have progressed since my last update. When stars die. When a massive star reaches the end of its life, it undergoes a powerful and dazzling explosion called a supernova. During this event, the star's brightness can increase billions of times, sometimes shining as brightly as a whole galaxy in just a few seconds. The energy released during a supernova is immense, about 50 million times more than the energy released by the Sun during its entire lifetime. There are 2 main reasons why stars go supernova. One is when stars that are more massive than 8 times our Sun run out of nuclear fuel. This leads to a collapse under gravity, causing a series of fusion reactions until the star's burning processes finally stop, resulting in a supernova explosion. The remnants of the star after the explosion can become a neutron star, or, if even more massive, a black hole. Neutron stars are incredibly dense and small, with radii of only a few miles, and they can rotate extremely fast. On the other hand, black holes are even more compact and have such strong gravity that nothing can escape their pull once it crosses their boundary, known as the event horizon. The fate of a star depends on its initial mass. Heavier stars have shorter lifetimes and are more likely to become black holes. Supernovae are awe-inspiring cosmic events that mark the end of a massive star's life. Type 1a supernova. In addition to the well-known basic mechanism that can lead to a supernova, there exists another fascinating process that involves a Type 1a supernova resulting from a unique double star system. This system comprises a white dwarf and its companion star. White dwarfs are compact, low luminosity, and aged stars. Over time, the white dwarf accumulates gas from the expanding envelope of its companion, leading to several nova outbursts, not to be confused with a supernova. These outbursts occur due to explosive ignition of hydrogen burning on the white dwarf's surface as it accretes material. During these events, hydrogen fuses, enriching the white dwarf's core with vast amounts of contaminated carbon. As the core accumulates more carbon, it evolves into an oversized diamond-like structure, becoming increasingly unstable. Eventually, it reaches a critical mass, and the entire carbon supply rapidly burns to nickel and iron, resulting in a detonation as a Type 1 supernova. Unlike core collapse supernova, no compact objects such as neutron stars or stellar black holes remain after this explosion. Instead, the dying white dwarf's matter is entirely ejected into the vast expanse of space. The companion star is also significantly impacted by this extraordinary event. Due to its high orbital velocity around the white dwarf, it transforms into a runaway star, rapidly flying away from the scene. It is truly a celestial dance of destruction and transformation, where these binary stars play a remarkable role in shaping the universe around them. The aftermath of a Type 1 supernova leaves behind a legacy of enriched elements, contributing to the creation of new stars and systems in the cosmos. Violent nova eruption. Recently, researchers from the Max Planck Institute in Munich made an exciting discovery while studying the precursor of a Type 1 supernova in a system called Ars Ophiuchi. This system is about 5,000 light-years away from Earth, located in the constellation Ophiuchus. It involves a white dwarf star that continuously accretes material from its companion, a red giant star. Occasionally, the accretion of hydrogen gas on the white dwarf's surface leads to overheating and triggers violent thermonuclear explosions known as nova outbursts. These nova eruptions typically follow a fixed cycle, with about 15 years between each eruption in the case of Ars Ophiuchi. However, the most recent nova observed by experts was accompanied by an unexpectedly high gamma-ray burst. Gamma rays are high-energy electromagnetic radiation, and in this case, they reached an incredible value of 250 giga-electron volts, making it one of the most intense gamma-ray bursts ever observed by astronomers. The explosion from the nova outburst produced shock waves that accelerated particles, including energetic protons, nuclei of hydrogen atoms, to speeds close to that of light. The scientists concluded that the intense gamma rays originate from these energetic protons. This discovery reveals that nova eruptions also serve as sources of cosmic rays, which are high-energy particles composed mainly of protons, but also electrons and completely ionized atoms. These cosmic ray particles travel through the vast expanse of the cosmos at almost the speed of light. While nova outbursts release significant energy, they are much less intense compared to the massive shock fronts generated by supernova. Nevertheless, one day, Ars Ophiuchi will eventually undergo a Type 1a supernova, tearing the system apart. This discovery challenges the notion that all objects in the universe must follow fixed rules and shows how diverse and fascinating our cosmos truly is. Stellar death throes. In the vast expanse of the cosmos, a cosmic spectacle unfolded that left astronomers bewildered. It all began in September 2014, when a massive star seemed to defy the laws of nature by refusing to fade away gracefully like ordinary supernova. At first, the event appeared to be a standard supernova, but an astute intern later uncovered a peculiar detail buried within the data. The star displayed an unusual pattern of behavior, flickering between dimness and intensified brightness, not just once but multiple times over a 2-year observation period. This baffling interplay of luminosity contradicted the established norms of stellar deaths, confounding the experts who had dedicated themselves to studying such celestial phenomena. To add to the intrigue, a deep dive into archival records revealed that a similar explosion had occurred at the very same location back in 1954, but had been overlooked at the time. Astronomers, including prominent figures like Stan Worsley, have grappled with this enigmatic celestial display, labeling it simply bizarre. The light spectrum analysis ruled out any other explanations, confirming that this was indeed a unique supernova event. Typically, dying stars fade away completely after about 3 months, but this particular star was determined to put on an extraordinary show for years. The quest to unravel the mystery behind this supernova hiccup is still ongoing. Researchers and scientists remain intrigued, offering various theories and hypotheses, but no definitive conclusion has been reached yet. This cosmic anomaly challenges our understanding of the life and death of stars, prompting profound questions about the nature of the universe itself. As we continue to explore the wonders of outer space, these enigmatic phenomena remind us of the vast mysteries that lie beyond our comprehension. Share your thoughts, suggestions, and feedback on this captivating astronomical spectacle in the comments below. And if you're hungry for more exciting cosmic discoveries, don't miss the other videos on our channel, which we've linked for you in the credits. Thank you for your curiosity and interest. Take care, and until next time, may the cosmos continue to awe and inspire us all.